Well, good morning. Today we're going to have a quick overview of the SMP structural modeling web application and what's been going on with it under the development, what features have been added and so forth. Plan is to do a short video about once a week just to keep people updated that are interested in what's going on. So since last week, I've added some user input validation to the program. Give a demonstration of that. Basically, if user doesn't enter anything, like you just press the button, what happens is you get a matrix of size 9. If that's not what you wanted, you can go back and you can enter should enter an integer here of the size of matrix you want. But let's say that you enter something that's not a number and you try that, and again, you'll get a matrix of size 9. And you can either accept that or go back and try again and then put in a number. Let's say you put in a number of size, say you want a matrix of size 2. So you put that in. What happens is you get a matrix of size 4. So this particular application will give you a matrix from size 4 to size 36. So if you try to put in a negative number that's less than 4, that will give you size 4. You try to put in a number that's greater than 36, it will give you a matrix of size 36. So kind of constrain the user's input here a little bit so that it makes the allocation and makes the user input validation a little easier. So worked on the detailed information in the cluster objects into classes function. So let's just take a look at that. We'll open that in a new window. Let's see if that comes up. It does not. So what we're going to do is we're going to switch to that window, walk through that a little bit. Okay. All right. So what I've done here in the detailed instructions in the cluster object in the classes description, so I've gone through and taken the information from Appendix 2 of the Interactive Management Handbook that describes the GMU ISM software and how the clustering command works. And so what I've noted here is that the colors in the matrix need to be changed. So what we'll be seeing here, we'll talk about that when we go through the matrix, but the colors need to be changed because this is a symmetric, the clustering is symmetric, and we need to address the colors differently. And so then you go through, and this outlines a step-by-step to walk through a iteration of creating the clusters as it's described in Appendix 2 of the Interactive Management Handbook. So step 1, you enter a number of 13. It's a 13 by 13 matrix. Then you press Display Cluster. They go through. It brings up to 13 by 13. Now here's the interesting part. So in the GMU ISM software, the computer asks you these questions. Is 1 in the same category as 2? And then you answer in the computer screen yes or no. That part is not into the software yet. We'll be adding that later on. So what you do here, you get the empirical information is you say no, but you don't do anything at the application interface. The way the application is right now, all you do is you respond if there's a yes. And so this is something that we'll walk through and do the algorithm. The human operator does the algorithm, and it's displayed in the matrix. It helps people see and understand what the algorithm is. So then the steps are all outlined here. Then you walk through, and then just complete all the steps. And again, note this is a draft document. We'll be updating it just to give people an idea of what we're doing here. So now we'll go back to the this main application interface. Let's find that. Here it is. Okay. Now, so as we're walking through this process, we'll just focus today on the cluster objects in the classes. So we'll enter the 13 here. Display that. Now, what we have here is that when we have an equivalent with clusters, well, I need to adjust the spelling in clusters, that's for sure. But when we're looking at these, it's a symmetric, they're the same as or equivalent is the natural language relationship. So actually all these red zeros on the diagonal should be green ones because objects are equivalent or the same as themselves. The yellow zeros would still be the same, but as we go through and work up the clusters, then the color combinations would have to be different. So this is going to have to be worked up and addressed in a different manner. So let's go back to the main application here, and I'm going to show, I've recorded a test on this, so I'll just run that as quickly as I can. And you can see here now that we've actually put the 13 in, and now what we've done with the 13, then we display the matrix, and enter the 2 and the 4 into the column number and the row number. And we press enter, and then of course the 2 and the 4 now are in the same cluster. So we have 2 and 4 here, and 4 has been taken out. So as we started here, we looked at 1 and 2, 1 and 3. We started at the top and worked our way down through these combinations. And that's what we'll do. As you can see, we now have a 2 class, 2 and a 4, but 4 is not here, so 4 is gone. So then the next one we'll do, enter 3 and 5. So 3 and 5 now are in the same class. Enter that. And we can see now we have 3 and 5. So we have 1, 2, 3. 6 is the next one we're looking at. So now we'll go through and see how that goes. So we now have a 1 and 6, right? So 1 and 6 are in the same class. So we'll enter that. And that's basically how it works. You just start at the top, start working your way down. The things that are in the... Now 1 and 2 are not in the same class. So there actually should be red zeros here where we have yellow zeros. So this, by next week, we'll have changed this color scheme to align it to what it's supposed to be. So then we'll just kind of walk through the rest of these specific inputs, show what that is. But as you can see here, we're walking through and clustering these, but when we have a 1 and a 1, a 2 and a 2, a 3, a 3, a 9, and a 9. Now these are all of the base groups. 11, 12, and 13 haven't been clustered yet. So these are the only ones we really need to discuss or find out the empirical information as we go through. So we have 3 and 11. Makes it smaller. We have 12 and 13 left. We know that 1, 2, 3, and 9 are our groups so far. Then we have a 1 and a 13, so we enter that. And then we have a 9 and a 12, and we enter that. So now we have 4 clusters, and these red zeros on the diagonal should actually be green ones, and the yellow zeros off diagonal should actually be red zeros, because we know these are different, they're not the same. So that's a process that we'll add next into the software development. We have, let's go back here again. So now we have not worked up a detailed information for either the strict order one object or the strict order one or more objects. We'll be working on that, but we're going to focus first on the cluster objects into classes. The specific document we have down here, cluster objects into classes. That document is available. We walk through this, and this is just a draft, but it's going to kind of give you an idea of what's going on with the software and where it's going, what the steps are. We go back to the front. So we're working now in this area on the cluster of the objects. And remember, we have very specific user interface validation we're working on. Let's say put like a 4.8 in here and a 3.9. What that does, basically, that's going to convert them into integers, and it's just going to take the first number. So that there are some rules behind here. If you put in the wrong type of input, in this particular case, if you put in not a number, you will get a series of errors out of the matrix itself. So it's a little bit involved, so I'm not going to show that right now. And basically go back. So we've got the strict order, one object, strict order, one or more objects, and that's the due priority out of the GMU software, ISM software that's in the Interactive Management Handbook, Appendix 2. We've split that one command into two here. A cluster command is the same. We're addressing the cluster command here, the same that's in the Interactive Handbook, Appendix 2. We haven't done the do model yet. So the do model is going to be a little more challenging. I think we need to develop some more concepts and some more definitions around that so we can clearly communicate which relationships go into which class. But that's basically where we are now, where we're going with it. And we'll have more in the next week. I'll try to do a little one every week or so. If you have any questions, be sure to send an email or email the list. Take care and have fun.